This video is going to be how to graph from Vertex Form and how you can get your vertex, your axis of symmetry, and the y-intercept when you're given a problem like this and you're told by your teacher that you can't use a calculator like is usually done. So let's go ahead and take a look on how we would do that. So first of all, when you're graphing from Vertex Form, there's some things that make it kind of easy. For instance, when we look at the vertex, our vertex, and I'm going to go ahead and just write a note down here on top of vertex. I'm going to put my brackets because it's going to be an ordered pair, and just remember that this value on the left is going to be your h value from the Vertex Form formula, and the value on the right is going to be your k value. In other words, k is your y value and h is your x value. Now there is some things that you have to remember when you're going to get that h and k value from the formula. So notice I did write this underneath there so it matches up. Notice that my a value in Vertex Form is 3. My h value is, I have this 1 right here, and k lines up with this -4. Now do keep in mind, and this is when you pull the h value. In other words, in this case, notice my h value right here, I have -1. When you pull that value down to using your ordered pair for your vertex, so I'm going to write vertex right here, make sure that you change the sign. So I'm going to write a note, change sign. In other words, notice this is -1, so when I write it for my vertex, I am actually going to go ahead and change it to a +1. If it were a +1, then I would change it to a -1. This is very important and is an area where you'll make a mistake if you don't remember that. When you remove the h value from your equation that's in Vertex Form, your quadratic, change the sign on it. Now when it comes to the k, we don't have that issue. Notice here my k form happens to be -4. So I'm going to take that k value and just bring it down and write it in there. So I'm going to go ahead and put -4. And now I have my vertex. So notice right, that's really quick and easy. You didn't have to do any math other than really just change the h value sign. So I'm going to go ahead and write that in. So my vertex is 1 and -4. So let me put that down. We have 1 for the h value, our x, and -4 for our k value, which represents the y value of the vertex. And I'm going to go ahead, I'm going to plot this on the graph as we write these things down. So let me find 1, -4. So this is origin where these two lines cross that I highlighted. So I'm going to go over to the right 1 time, and then I'm going to go down 4 times. So 1, 2, 3, and 4. So this is going to be my vertex. So I'm going to go ahead and write right here 1, -4. And then I'm going to put vertex beside it. So notice, right, we got that easily from our equation. Now we need the axis of symmetry. Well, always remember that the axis of symmetry really is just our h value of the vertex. And because it's in the location of x, it's always in relation to x. So this x value that you see right here, this 1 that we have, I'm going to circle. I'm going to put right here, x is equal to 1. And that is my axis of symmetry. So I'm going to draw that right quick on my graph before I do anything else. And you're going to see how that's going to actually help us be able to graph this function. So I'm going to get my protractor, and I'm going to draw a dashed line. Right, and I'm just going to write right here, put an arrow. This is my axis of symmetry. Also known as our AOS. So next, in order to finish graphing this, right, we have to have another point. Even with the axis of symmetry, that's going to help us find our third point without having to do any mathematics. But we do need to find one other point other than the vertex in order to be successful at that. So what we want to do is we want to find the y-intercept. So in order to find the y-intercept, that is going to take a little bit of work. But what I want you to remember is that anytime we have a y-intercept, it's where it crosses this y-axis, right, this orange line. And anytime something crosses on this orange line, it is lined up with 0 for the x-axis. So when it comes to my y-intercept, I'm going to go ahead and start writing my ordered pair. For x, I'm going to put a 0 value. And all we really need to find is what the y value is. Now, the reason I'm making such an emphasis about the 0 is because we have an equation that they gave us, and we can simply substitute 0 for the y value in our equation and then solve for x, and it'll tell us what our x value is to the y-intercept. And if that sounds confusing, let me show you what I mean. I'm going to go ahead and I'm going to work it out over here on the left, but I do want to rewrite my formula that we're going to be using to work this out before doing so. So I'm going to go back to the original formula we had up here at the top. This y equals 3x minus 1 squared minus 4. So let me go ahead and write that. So I have y equals 3 times x minus 1 squared minus 4. Alright, now that I have this, I'm going to do what I told you. I told you that I know that when I have a y-intercept, my x value, and I'm just going to put an x underneath it, that's my x value. This is my y value in my ordered pair. But I notice that x is always 0 where it crosses y. So I'm going to go over here to this x and replace it with a 0 in parentheses. So I'm going to rewrite this now. This is y is equal to 3 parentheses times my x value, which is 0 because we're looking for the y-intercept, minus 1 close parentheses squared minus 4. And now we're just going to solve this for y because we just have one variable. When we find that y value, that's going to be the y value from my y-intercept. So let's go ahead and do the math here. I'm going to stop writing y for just a moment and start working this out. So I'm going to rewrite this as 3, and 0 minus 1 just leaves us with negative 1 squared minus 4. Now remember, when you have a negative value and it's in parentheses, right, if you wanted to write this out, it's actually going to be negative 1 times negative 1. That's what negative 1 squared means. I'm going to bring down my 3 and bring down my negative 4. Now I know most of you know this, but I just want to show every step of how I'm getting the answer I'm getting by doing this by hand, since the teacher may ask you not to do it with a calculator. So we have negative 1 times negative 1. That gives me a positive 1. Now keep in mind that as it changes into a positive 1, 3 is still outside the parenthesis and needs to be multiplied. So I'm going to write 3, and I'm going to leave that positive 1 in parentheses. And I'm following order of operations, which says we have to do multiplication before we can do addition or subtraction. So the last thing we're going to do is subtract this 4. But now I'm going to take this 3 and I'm going to multiply it to this positive 1, because a parenthesis just means to multiply. So 3 times positive 1 ends up giving me 3. And then we still have our minus 4 at the end. So I'm going to put minus 4. So 3 plus negative 4, or 3 minus 4, depending on how you like to look at it, is going to leave me with a value of negative 1. Now I'm going to go ahead and bring down the y. I've been leaving off the equal sign of the y, but it was there. So I have y is equal to negative 1. And that's going to be my y-intercept. So I'm going to go ahead and take that value, right? We did all this math right here, solving for y, just so we could find that negative 1. And I'm going to write it into my ordered pair for the y-intercept. It's 0, negative 1. So now I'm going to go to this y-axis and find 0, negative 1. So here's 0, 0, down 1, that's 0, negative 1. I'm going to put a point right there. Now, when I was having you use calculators, or any of my tutorial videos, if you watch them when we're graphing one of these, I always tell you that you got to have 3 points to graph a quadratic, and you do. And so you may be looking at this going, well, you know, Mr. H, we don't have 3 points. We only have the vertex and we have the y-intercept. So how can you finish graphing this function? Well, what I want you to think about is, this is the axis of symmetry. In other words, it makes a mirror image of this shape on the left and right side of that dashed line. So what I do is I'll just go from the vertex and follow it up, and then go to the left until I see my y-intercept, and I'll count how many units away from the axis of symmetry it is. So this is left 1 unit. So if I want to make a mirror image, I'm going to go to the axis of symmetry and then go to the right 1 unit and put a point here. Notice I didn't use any math. I just recognize if this is my axis of symmetry and I'm making an image that looks like it's being in a mirror, right, that both sides have to be equal to each other, they have to be congruent, then I can just count the distance away to the y-intercept and go the opposite way from the axis of symmetry and put my second point and then write its location. Now this is actually going to be located at 1, 2, and down 1. So I'm going to go ahead and put positive 2, negative 1. Now I have 3 points, and I can go ahead and draw my graph. So I am going to go ahead and draw it real quick. And it's going to go from here up here. Now this is just a sketch, so I'm not worried about trying to get the x-intercept right or anything like that. I am just drawing a sketch of the graph. So it doesn't have to be perfect, but it gives you an idea of the direction it's headed. And I'm finished. I found my vertex. I found my axis of symmetry. I used math to go ahead and find my y-intercept. And then I used that axis of symmetry to find where I should put my third point so that I could create the parabola. And that's all there is to it.